So just like out of curiosity, how many people here have played Subway Builder? Wow, that's a lot of people. When I made this game, it was my side project. I think I started almost a year ago now. So it's crazy to see how fast that's blown up. I also did not expect this many people to be here today, so apologies in advance if this presentation was a little bit ad hoc. But first, a little bit about me. I went to school at the University of Portland in Oregon to study computer science for a whopping 1 year before I made my first startup, Redistricter, which is a political data analysis platform. I did that in the summer after my freshman year of college, and then that took off. So I dropped out and left Portland to come to New York, and that was about 2 years ago now. And then, as I said, a year ago, I made Subway Builder, and then I launched it in, I think, October. So why did I make Subway Builder? Um, I was taking the 6 train back home, and I don't know why it just stopped working. I was going from like Brooklyn Bridge City Hall to Spring Street, and it got stuck somewhere in the middle for like 10 minutes or something like that. I was annoyed, but then I started thinking about subways, and I thought, well, it would be cool if there was a game where you could make your own subway system that didn't have that problem. So I started brainstorming, like, okay, like what are the things I wanted for my game, like what's the bare minimum? So you need functionality to create routes and tracks and stations and all that. So construction. You need a way for the game to move the trains around automatically because you're not going to be wanting to press the gas and the brakes for every train all the time for the entire MTA system. And most of all, I wanted a really cool and realistic passenger demand system. I wanted to accurately model where people in real life go to and from and use that to incentivize the user, the player of the game, to build a system that would be useful in real life. So I'll just go over those 3 things, starting with construction. I did some experimentation and I realized that the game is not going to work with American construction costs because it's very expensive. And I don't have government funding in the game because I didn't want this to be a political simulator. I also didn't want this to be like a city builder. So I scoped it to just transit. And because there's no government funding, I've got to use Portuguese construction costs. Use American costs doesn't work. And just like in real life, the costs are variable. So it depends on the elevation. So if you build a tunnel super deep, that's going to be a lot more expensive than if it's just laying there on the ground. And also depends on the type. You can build type of subway, you can build light metros and heavy metros, and there'll be other types of train sets coming soon. And I got a lot of these costs from the NYU Transit cost project. Very useful if you haven't checked that out. And also, just like real life, you have to contend with existing roads, ocean and river topology, and building foundations. So right now, I'll actually hold on. I'll do a quick demo of the construction setup. So let's go start a new game in New York. So what I can do here is set up the construction panel. Let's build the station, 14th Street. And you notice over here, it's at -4 meters, the elevation of the tracks. So if I try to build it over here under the East River, it's not going to let me because it has the real world elevation for the East River. So I'd have to dig under that at an additional cost. And you can also see over here, if I try to build through buildings, it will let me do that, but it'll force me to demolish the building since this will collide with the building foundation. And what's really cool is the building foundations are variable. Obviously, I couldn't find an actual data set for building foundation depth, but you can make a pretty good estimated guess based on building height. And I could get all of that data from OpenStreetMaps. So you can see over here in Midtown, there's a lot of these super tall buildings with deeper foundations. So if you're building subway tunnels in Midtown in the game, just like in real life, you'll have to contend with all of that. And yeah. Anyways, so that's construction. And then passenger. And so then dealing with demand, I took note from a game I used to play a lot because I'm a huge nerd called Victoria 2, if anyone's heard of that. It's a 19th century economic simulator. And it splits the entire world in like 1850 into groups of several thousand people to make simulating the entire world easy because you can't simulate a billion people. Well, you could, but it'd be very difficult to write a program that would simulate a billion people and not lag constantly. And so what I did was I split, I'll take a big city like New York, about 8 million people. You split it into groups of about 200. And I call each of those groups pops, just like in Victoria 2. And each pop has a assigned work node and home node. So first, what I had to do was generate a bunch of work nodes. And I got this from the census data set called LODES or LODES. And it has real world records of where people go to work. And I agglomerate those into these little dots. You can see that here in the bottom left, each of these dots represents a work node, and the size of the dot corresponds to how many people work there. And then I get the residential nodes, which is the same thing, same data set, except instead of workplaces, it's residences. And you can see how most of the people work in Midtown or the financial district, but they live all over the city. And so your goal in the game will be to get people from over here to over here. And you can see in the, you can up it. And so after I created all of the nodes, I had to assign the pops, every pop to a home node and a work node. And I did this using a gravity model. So it's semi-random, but the way it works is areas with more work nodes, like in Midtown, they'll grab people from all over the city, just like in real life. And you can see an example of that over here. This is center of this is a work node in Midtown, and all of these lines radiating out represent a pop commuting to that work node from a different home node. And it's the same thing in the middle, except that work node is in Brooklyn. And so you can see, just like in real life, the people working in South Brooklyn generally live within Brooklyn, but the people working in Midtown live all over the place. And so I had the home and work pairings, and then what I had to do was figure out the driving and walking times to get people, or how long it takes to drive or walk from their home to their workplace. And I can just pre-calculate this. This isn't done in the game, but I just use OpenStreetMap data and speed limit data for all of the roads in New York. And I just plug that in, and then you get a path. I'll give an example of this. Like, hold on, it's not. Sorry, it's not working. This is my developer build. I should have used the production, but it would show you a path from their home place to their workplace. Anyways, and they also have a set departure and arrival time. Just like in real life, they cluster towards rush hour, but not always. Sometimes people go to work at 3 a.m. and leave at noon, but most of the time they'll get to work around 9 and then leave at about 5. So now you have the passengers all generated, but now you have to make the passengers interact with the transit systems that the users build. And this is the hard part because I can't pre-calculate that. And I have to run a pathfinding simulation like what you did to get to this place in downtown Brooklyn. You have to punch it into Apple Maps or Google Maps or whatever, and it outputs a path. It'll say, take the J to the F or whatever. I need to do that for 10,000 different pops in New York City based on a dynamic transit system that changes all the time, and it needs to be fast. So I came across this Microsoft paper on a type of pathfinding algorithm called Raptor. I don't know what kind of acronym. They didn't use the B, they used the A, but whatever. Basically, the way it works is, you set your origin and your destination, and then it works in rounds. So on round 1, Raptor will look at your origin, and then it'll see, okay, you're at this station. What are all the different other stations within the system that I can reach without transferring? And these are all the different blue dots. And after round 1 is done, it'll say, okay, well, round 1 wasn't enough to get us to the destination, so let's do round 2. And it'll look and see what other stations and lines it can reach from every station in round one. And it'll just keep going until it finds a few different paths to the destination. And it'll go through the different paths that it found and just pick the fastest one. And here, I'll demo this right now. Let's, which one do I go with? Let's use this one. I play this game a lot. So a lot of save files. Okay, so there's this tool I have this is just for visualization, this tool called the Journey Planner. And so I can pick a spot on the map, an origin and destination, and it'll output the path that the game wants me to use. So it's telling me, if I'm starting at the green dot and ending at the red dot, I should walk to this station over here and then take the orange train. And it also takes into account transfers, as I said. But yeah, so that's an example of how pathfinding works. Oh, and train movement and signaling. This is just a quick visualization. So the white dot or the white lines over here represent trains moving along tracks, and the green, orange, and red lines represents parts of the tracks covered by a different signal. So red means that that signal is occupied, orange means that it is about to be occupied, and green means that it's open. So this train over here, you can see it had to slow down because it sees that this signal ahead of it is red, because another train is occupying it. And this is all to just keep them from running into each other. It's sort of modeled after the CBTC system that the L train uses here in New York, but a lot more simple. And yeah, so I thought that's pretty much the basics of how Subway Builder works. And I'll show like a bunch of different like visualizations you can do in the game because they're pretty fun. You can see like how many riders are on each route, and then I can click on a route. This is the red train. Show me all the stations on this train, and I can even see the number of riders, and I can just keep going more in depth. So like how many riders is this line getting per hour? How many people are transferring onto the red train per station? Which ones are popular for getting to work? Which ones are popular for getting to home? All that stuff. And you can also see the transit choice for everyone living in Philadelphia based on your design. So you can see that the yellow dots represent areas where more people are taking the train to work, and the purple dots are representing areas where fewer or no people take the train to work. And as you would expect, the yellow dots kind of conglomerate near the stations. And you can see the same thing for work nodes. What else? This is just fun. This doesn't have any functionality, but I do like the 3D buildings. This took forever to replicate. I think it was like 2 weeks full time just trying to get these buildings to show up and for the lines to show behind the buildings, but I'm pretty happy with how it turned out. What else? Oh, and
speaking for Philadelphians, we appreciate you giving us more subways.
Yeah, I love Philly. It's a good city. And I'll slow down. So you can see right here all the trains moving around in real time, and the red dots represent groups of people moving on the trains or they're moving to and from a station. And in real time, every 15 minutes of in-game time, a new set of commuters will make the pathfinding decisions, like deciding which trains to take, if they take any train at all. And one other thing, I should have mentioned this earlier. Here, you can click on a demand panel. So these are all of the residents in this demand node in like downtown Philadelphia. I don't know the neighborhoods very well, but and the lines represent different work nodes where they're going to. And I can click on one. So I'll click on this one. And this is the driving or walking path if they wanted to walk, but it's kind of far to walk. This is the driving path that they'd use. And this is the train that they would use. And you can see that driving is a lot faster, but still some people will take the train because within a pop, there are different groups of people with different incomes. And they make the decision whether to drive or take the train based on the value of their time per hour, which is variable. And so you can see that for people within this pop group with less income, they're more likely to take the train, but then that cuts off at some point, and everyone above this income, they drive. And here are just some work in progress features. You can see on the right, I wanted to just show interlined routes right next to each other. So that's hopefully coming in the next few months. And here's a 3D mode that is also a work in progress, but that will take some time to finish up. And one thing I'm really shocked by is how many people play the game. Like I go on here, I can check right now. If you go on subwaybuilder.com, you can see like a live feed on how many people are playing the game by city. I like checking it. It's kind of fun. And people make like the craziest maps. The other day, this guy emailed me and was complaining about bugs, but like his map looked like this. I was like, it's like, you're out of luck, man. I don't know. Yeah, so I do want to keep working on this. It's my full-time job right now, Subway Builder, and I have some people working with me in New York. There's like all sorts of, I didn't list this here, but I want dynamically generated cities too. So like cities that don't exist anywhere, they're just made up by the computer, and your town grows around the train system. I also want dynamic growth on actual cities that exist in the game right now. So like, you build a train from, a new subway line in New York, then the neighborhoods along that subway line will grow because people want to live by the train. I also want to add different modes of transport. I want to add commuter rail and ferries and buses and all that stuff. I also want to add non-commuter demand. Right now, it only does students, commuters, and people going to the airport. I want to add leisure demand. So people are just, taking the train to Central Park or whatever, going out for a night in the Lower East Side, whatever. And this is like a pipe dream, but I would like to see this used for actual transit agencies. But I don't know about that. We'll see. If anyone at the MTA wants to talk to me, I'm always open. That's it.
Great. Thank you, Colin. Let's open up for questions.
First of all, thank you so much. I have a question. So do you do like user interviews? I'm curious what users want, and also curious how you do like marketing or like outreach, or like how do you like find like fundings at your full-time job?
Funding, it's all like self-funded. So there's no outside funding. And as for like marketing, it's mostly just organic. It started off entirely organic. My Instagram page is run by someone else who specializes in that kind of thing, but everything else is just me posting online. Like my Twitter presence is just me. And Reddit, I'm not posting there. It's just every other people post Subway Builder onto there, so I don't even have to work on that. That was everything you asked, right?
Like, I was wondering what users want. Do you know what your users want?
Yeah, I do regular like Q&As on the Subway Builder Discord channel, and that's usually how I get like a good idea of what people are looking for in the game.
What are they looking for?
Right now they want the Los Angeles map really badly. It's not working for technical reasons, but hopefully soon.
Could you high level tell us what technologies you used or are using as part of developing this?
Yeah, it's actually so most of my experience in programming is web development. So it's mostly just made in React, and the 2D part of the map is built with MapLibre, and the 3D part is like a kind of weird fork of NPM package called DeckGL, and it's all packaged within an Electron application.
Question about the rendering is impeccable. Did you like specifically program for that, or
Sorry?
the map rendering is impeccable. Like you can zoom in, zoom out. It's not static. It's just seamless. Did you deliberately like code for that, or is that just a product of a function of the product you're using?
It's kind of just a product of MapLibre. It's a really good technology.
Okay.
You talked about the cost as an example of this, but there are other things that you found that if you made it lifelike were just not fun in the game or kind of too complicated to put into the game?
Nothing off the top of my head. There are some lifelike things that are kind of difficult to add, and that's part of why I haven't added them. But I'd like to think that most of the real struggles of a transit agency are kind of included in here. Other than that, it's just made a lot simpler.
You went, sorry.
Oh.
You went over a lot of the model. How did you make the assumption on parking costs and driving costs?
So for driving costs, it's just I found some DOT data for fuel costs and for depreciation of a car based on miles driven, that kind of thing. That was the easy part. Parking costs is in reality very variable, but I just use a flat base rate. I do want to add in the future a parking cost that's dependent on density level.
So I think everybody's really glad to see the dynamic population growth and like the idea of induced demand being here. So I'm wondering, like, when you started this, you obviously took a baseline from a census reading, right, of a city at a time. Have you considered maybe like the fact that New York City's population, the pops of New York City or any city, was itself induced by transit development before we got to that point, and like thought about going historically back?
Absolutely. Yeah. So originally what I did was I didn't use the gravity model to assign people to their workplaces. I used the actual origin destination pairs. And what I found is that, you know, unsurprisingly, especially in a city like New York, people just live along the subway line that will take them to work. And so when you build the demand system like that, it's really just overfitted because it then just incentivizes you to build the existing transit system and not experiment with new things.
Regarding development for the game itself, what were your biggest headaches for creation?
The 3D buildings, I wouldn't have done that in retrospect if I knew how long that would take. The pathfinding is it's very hard.
In terms of features, do you had to plan like fare optimization or train optimization to make people who like focused on population building instead of just like the economics of it?
Sorry, could you repeat that?
Like when I play, I like really wonder how many trains, like I'm doing a New York one right now and I have like a lot of overpopulation, but I want to know, like, I don't really know how to balance the economic costs versus like how many I should have running. So do you plan to make it that you can optimize that, like so you don't have to do it? But just more like I like the building standpoint of it more than like the technical like that.
Yeah, that could be cool. Yeah. I haven't thought about that before, but yeah, that would be a neat feature. Whoever wants to speak first, I don't know.
Okay, let me go. So are there any challenges in data that you kind of encountered or you wish the data existed and you actually did not find the data existing?
Yeah, so like right here, actually it's not right there. Oh yeah, the non-commuter demand. I do want to add leisure demand, but there's no data set or at least not a unified national data set saying like how many people are going out for a night on the town in West Village, you know, like that's not, the census doesn't record that kind of thing. And there might be data on like how many people visit the Bronx Zoo, but that's one data point. I can't get that for an entire city really easily. And so how I plan to solve that and other issues with lack of data is by crowdsourcing it. Because luckily I have a lot of players and a lot of them are willing to find data, you know, every single data point needed for that kind of thing. But yeah.
Well, thanks.
Okay. Hi. Yeah. Thanks so much for the presentation. I'm Franklin. I'm part of the Transit Cost Project. So thank you so much for using our data. We are constantly updating a lot of the more rolling stock focused data these days. And just to comment on your current model, I wonder how much of the census data were you using the latest 2020 census, 2020 to 2021 census, or were you using an older data set because the census, the demographics change every time these things are updated? And I have a follow-up. Thank you.
I think the loads data set for the census, it updates like irregularly depending on the state. So for some states, the latest the latest data is from like 2023 or 2024. For some of them, it's 2020. I don't off the top of my head know which states are which, but they're no more than the data is no more than 6 years old.
Okay, and my other follow-up question is, would you consider updating the model with, for metro areas that have better data for trip times? Like, for example, our group is currently trying to utilize the Federal Transit Administration's stop software, of which one of their components is highway travel times between the transit access zones. And subway trips are more competitive when there's like a benchmark to benchmark against, and that's how they use that part of information to deduce whether one person would choose a subway trip over a driving trip. And one of the data for New York City is from NIMTIC, which is the New York Metropolitan Transportation Council, of which they updated transit trips and the highway travel times. Would you consider implementing these kind of data in your model in the next future builds or so that you can actually further quantify these sort of demand attraction versus car trips?
Yeah, that'd be super. I haven't heard about that before. Yeah, that'd be really interesting.
Number one, thank you for the presentation. So you said that you've played this game a lot, and at the risk of stepping into controversy, are there any like dream transit lines that you would build in New York or elsewhere?
Second Avenue subway.
Okay, I think you picked the least controversial thing.
I have some familiarity with the St. Louis system. I know for a fact that their highest demand is actually sporting events. So if you could include stadiums and the like, I think you'd find a much more realistic view of things when you do non-commuter demand.
Oh yeah, no, totally. That's definitely something I've wanted to add for a while, but for the same reason I haven't added leisure demand. You know, there's no standardized data set, but I'll crowdsource it.
Yeah. St. Louis probably has the data you want.
No, I understand. I mean, like it's not standardized across the entire nation.
Oh, of course.
Yeah.
And second thing, I haven't had the opportunity to play the game yet. Do you take into account distance pricing, or do you assume flat fares?
It's flat fare based right now, but I do want to add an option for people to implement fare zones within the system, kind of like how London works.
Yeah, this reminds me of something. I've lived in San Diego as well as Philadelphia, and one of the differences of choosing to drive over not driving has to do with the pain of parking, the pain of like the width of streets and things. Like, how do you take into account that difference between in San Diego and Philadelphia about how easy it is to drive in San Diego versus how hard it is to drive in Philadelphia?
I don't, not right now. I do want to add that over. I do want to add that at some point, like variable parking prices based on location. So, you know, it should cost more to park in downtown Philadelphia than like suburban San Diego. And I think the way I would do that, unless I can find a data set that has parking costs over different geographies, I would just use a density-based model.
Yeah, something, because it's really, I mean, just even during the regular rush hours, whatever, it's just the streets are so much better and the parking so much better in a place like that. Comparatively, it's really hard to drive in Philadelphia most of the time.
Hey, Colin, super dope talk. Thanks for talking about it. I was curious, you talked about how, it's hard to model like 10 million people, so you break it down into like pops. But then you also showed how, within a pop, you might have like an income distribution, and that affects like how certain people commute. I was wondering, how are you able to break down the pop like into like these smaller divisions that without kind of defeating the purpose of having a pop and needing to model like every single individual person?
Yeah, so really the expensive part of splitting the pops into smaller groups is running the pathfinding calculations a greater number of times. And so within like that group of 200 people I showed, it's only running one pathfinding calculation. So for all of the people in that group, since they have the same home and work pairs, they're getting the same result. But once I get the pathfinding calculation done, then I can split them up into income groups and then separate them there.
So I have more of a big fan of the game, played it a lot. I probably not the only one that's also played like SimCity as a kid, right? To get to this. So my question is like, would you consider adding not necessarily like earthquakes or tornadoes, but you know, freak accidents or random delays or more like obstacles, I guess, in general that match kind of the real world challenges a subway system faces?
I've thought about it. Maybe it could be like a mod or something. Right now, you can actually run into delay issues if you structure your route network kind of strangely. Like if you create a lot of merge conflicts on busy routes, then trains are going to be waiting for an open slice of track to merge into for a long time, and that can create delays that cascade just like in real life.
I was so happy to see Pittsburgh included on the initial launch. I grew up there, and boy, is it silly that the only rapid transit or train-based transit goes into the South Hills, where I'm not from, and I don't consider anyone living there to be from Pittsburgh. Really, just kind of at a high level, curious about the architecture decisions that you made in building this. I mean, it's unbelievably responsive and boots up so quickly. I mean, it's just and all of these iterations that you've made and improvements that you've put in seem to be added in rapidly. So you're doing something right. I'm curious to learn more.
Well, at this point, I have other people working with me, so it's not just me. I don't know. I would say that especially for creating UI stuff, React is like super fast. You know, you put React on top of like Claude Code or whatever, and then it'll just like spit out new stuff like all the time. So if I was making this like 3-4 years ago, I don't think it would be developing at the same pace. AI is just super useful.
Are you planning on adding, or do you already have like social or network feature where you can like build with your friends or see like what other friends are working on?
So I don't have multiplayer in the works right now, but I do have this little share screen that'll be out in the next version, 1.0, which I think will come out either this week or next. And you can click a button on your game, and then it'll create a cute little map that you can share to Twitter or Reddit or whatever.
So you are using Claude Code?
Yeah.
Is that your preferred IDE? Is there anything else that you're using, like Cursor?
I use both. I use Cursor for the autocompletes and then Claude Code for more complicated stuff.
Sorry, it's not an IDE, but yeah, for a coding assist.
Yeah, I'm super interested in the kind of trade-offs with regards to pathfinding algorithms. Like with Raptor, for example, is it the case that the pathfinding would prefer like a single line trips, even if they're longer, versus trips of transfers? I'm curious what the trade-offs are in like computation cost and accuracy of different pathfinding algorithms and how you settled your choice there.
Yeah, I tried a Dijkstra-based algorithm, and I just found that Raptor is just so much faster. That's the main reason I picked it. There are still issues with the pathfinding algorithm in Subway Builder, and part of those are inherent to Raptor, and part of those are just my implementation of it. Like for example, it really, as you said, like it disincentivizes transfers probably more than it should. I think the people, like the pops within Subway Builder, the commuters, transfer like 60% the amount of time that they actually should be transferring. So a lot of mistransfers, but it's better than every other algorithm that I tested.
Hey, Colin. Right. Thanks a lot for your presentation. It was really fun. I personally happen to be a UI UX designer, and yeah, I really like how you used the cursor to build the whole thing. When you were designing it, what was the design process like and the prototyping? I know this isn't really about that, but did you use Figma MCP to design some things, and what was your whole process around it? And how do you use AI for the whole design process using for user research and then prototyping? I know Cursor is a big one and Claude Code as well, but if you could just shed some light to it, that would be really helpful. Thanks.
So for the UI and design, I don't know how to use Figma, so I just use notepads. Just kind of sketch it out in my mind and then figure it out from there. You were just asking about the UI design, right?
Yeah, but do you, when you were conducting your research, I'm pretty sure you must have, did you use AI in the whole process as well, or did you keep it completely strictly to your readings and did the literature review and everything on your own?
I tried initially, I was lazy. I was like, I'll just get like Claude Code to like sketch out the high level architecture. And then I realized it's not very good at that. So I just had to do it myself. I just like figuring out, like experimenting with different packages, different types of maps, different pathfinding algorithms, like all sorts of stuff until I got the right fit.
And are you still I'm sorry about that. Are you still keeping it self-initiated, or you're just working with more and more people, or you're bringing up more designers or engineers who could handle the more backend stuff, and if you could, yeah, make it a bit larger.
I'm working with some other people right now on Subway Builder. Most of them are based in New York. I'm not hiring anyone new right now, but at
That's
this
really cool.
point, it's probably
Thank
like,
you.
okay.
So just to get a little bit more into the method of things and really more like personal investment in this, I guess my question for you as someone who decided after a year undergrad wasn't really the path you wanted, who founded a startup, who built something like this, which takes an enormous amount of discipline and skill. Could you just shed some light on, how you manage yourself, what your workflows look like on a day-to-day basis, and I guess how you stay motivated and keep a project on track?
I'm probably not a good model because I'm like very erratic. Like I was not supposed to be working. I was supposed to be working on Redistricter, which was my full-time job. It's still my part-time job. I did this for fun because I got distracted, which is the same reason why I created Redistricter. It was like final season. I wasn't supposed to be working on it. I didn't expect anything would come of it. I just thought it'd be fun. So I don't have any like secret method. I just like making things.
Yeah. In continuation of that, I was very curious about like what was the motivation for this, and then how like I would love to learn more of the broader timeline. When did you like start working on it? How long did it take? When was the first like pickup of like users and launch?
So I think I came up with the idea in like late December or January of 2025 or 2024. And then it was part-time. I was maybe working at like 10, 20 hours a week. Then I went on vacation for a month. And then I came back and then I was working on it full-time because I tweeted about it and it got a ton of reactions, like 30,000 likes or something. I was like, okay, I have to make it at this point because I think people will buy it. And so then I worked on it full-time from summer until October. And then I launched the public beta. And then since then, it's been full-time.
Thanks for the talk, Colin. And yeah, Subway Builder is super fun to play. I also had questions about the use of Raptor. So when you have like in your game, you have a bunch of origin and destinations where pops are very co-located with each other. Like in the case of Midtown, you have a lot of pops going into Midtown Manhattan. Have you thought about doing any sort of caching, or are you doing any sort of caching when a lot of trunk lines are being used at the same time with like similar pops that are co-located? Because I think that would help improve your runtimes a little bit.
So right now it doesn't cache anything. Someone working with me on Subway Builder has the idea you had, and I told him that I thought it would be a bad idea, but he strongly disagreed with me. So it's currently a work in progress. I'm not sure if it'll work. My theory is that it's not going to work because I had mentioned earlier that like delays can cascade just like in real life if you have different routes merging onto the same tracks and they're running at high frequency. And so when you get these delays that deviate from the schedule, then the previous cached route is now invalid because it's looking for a train that is either ahead of schedule or behind schedule. And so it's not going to catch that train. And so if the frequency on that route that it's trying to get is lower, then it's just going to be waiting at the station for a really long time.
Got it. And just one more follow-up. So you use Raptor for the transit pathfinding. What do you use for the driving pathfinding?
There's this package, this Python package called OSRM or something like that. It uses OpenStreetMap data, and the OpenStreetMap roads, a lot of them are tagged with speed limits. And so then it uses those to estimate driving times. It's not as good as like the Google Maps API for pathfinding, but the Google Maps API is like really expensive if you're pinging it like 10,000 times. So I use the OpenStreetMaps package that I'd mentioned, and it's like deviates from Google Maps like not that much, maybe like 10%.
Is it OSMNX?
What?
Is it OSMNX that you're using?
It's called like OSRM routing or something. It's an
Oh.
acronym. I can't remember what it stands for, but
Thank you.
You mentioned that making the buildings render in 3D was difficult. And I was wondering if you could elaborate on why that was difficult and also where you're getting the data to make the accurate 3D buildings.
yeah. So, well, let me clarify. It's actually, I'll show you. It's not really the 3D buildings that's difficult. The data for the 3D buildings exist in OpenStreetMaps. Most of the buildings are tagged with their height or like how many stories they have, and then you can use that to approximate height. The problem is I wanted this like Apple Maps-esque look where like you can see like the routes over here, and like when I like pan so this building is over the station, you can still see the tracks behind it, but the tracks are at like a lower opacity than the tracks not behind this building, and it's really nitpicky. I just wanted it to look really good, so that's how I made that. That was the hard part, the occlusion.
When you launched the Q&A, you were adamant you were not going to have buses in a game. What made you change your mind?
I saw a graphic the other day about like how many people ride buses in New York. So the buses that's the really hard one to do because well, it's hard in a city like New York because for performance reasons I need to keep pop sizes big, like 200 people. If you got 200 people traveling at once, they're all not going to get on the same bus, you know? Buses don't fit 200 people. That's the main reason why. The other reason is like well, it's like a gameplay standpoint. Here, I'll like MTA buses, Brooklyn. There's like a lot of buses. You can't actually, let's see. Here, like these are all of the, oh. I'll let that load, but there are a lot of buses in just Brooklyn, for instance, you know? And so like there's hundreds of lines within the entire New York system. To accurately add buses within the game, I need to either like just add like bus rapid transit or I mean even then that'd be a lot, or make some sort of like AI system that would draw the routes for you. I don't know. I don't know how to deal with it.
Is there anything you'd do differently if you were okay with requiring users to have a more powerful machine to run the game?
No, not really. Not that I can think of.
Are you planning on like adopting different systems in one city, like Metro North, like New Jersey Transit, Path, like different fare, different systems?
No, because that's like those are the sad realities of politics. I want a utopian. I want a utopian system. Everything should just be one system. I do want to add commuter rail though.
Thank you. This is great. Did you include congestion pricing in the system?
No, I didn't, although that could be interesting.
I think you just answered this, so maybe it's not a mute point, but when you say one system, I guess, is there any like, maybe one political system, but would it be a large, I guess, would it be possible to have like different systems modeled separately and run separately, and then thinking about how to interconnect them so you can run the game in multiple cities at the same time? And see how
that'd be really hard. You'd have to run for every new city. That's an extra simulation to run. It'd be kind of performance intensive. I think intercity rail could be interesting. I don't know. That's maybe like far down the road.
Thanks.
Like OpenTTD.
That was my question, I guess. Are there any transit games that inspired your design decisions for Subway Builder, like OpenTTD?
You know, I've watched OpenTTD on YouTube. I haven't actually played it. But I guess City Skylines, I used to play a lot of that. I would say it's maybe more modeled after like Victoria 2, the that's kind of what I based the architecture of the game off of more than like any transit or city game.
We have a couple of questions online. I already know the answer to that, but I'll let you answer it. But somebody asked about the cost of the game. Is it a one-time fee or a subscription fee, and how
It's
much
one
is
time.
it?
It's $30.
All right. And then the other question, have you encountered any performance issues, particularly with large cities as the map and train activity potentially becoming more complex? If so, at what point do they show up?
So yeah, they show up, I don't know, maybe like once you get to like maybe half the size of like the MTA system in New York, that's when the lag starts showing up. And then once you have like a system kind of like the screenshot I showed, the one user submitted that system in Minneapolis, once you get to that point, it's like really starts to drag on. It's gotten a lot better since launch. I would say that it probably runs like 2 or 3 times faster than it did a few months ago. And I have some performance improvements also in the works that might also have for, you know, that will also just make everything much faster.
Any further questions? Yes.
You mentioned that there was a pretty heavy penalty with the Raptor algorithm for transfers. Is there any plan to modify that in some way?
Yeah, there's a few different strategies. I'm trying to remedy that. It's really just kind of a lot about experimentation, trying different things.
Okay. If there are no more questions, I'm going to ask my question. And you do not have to answer this, but do you mind sharing how many downloads you've gotten so far?
I'd rather not, but growth?
Yeah.
What do you mean?
How much has it grown since it launched month over month?
Like percentage wise, maybe like half of the downloads came in the first month, and then like week by week after that, like as I would expect, they like start to dwindle. But then they pop back up whenever some like big YouTuber does a stream or something like that.